to the 7th power, which you could multiply out if you really felt like a huge number, but we can leave it like this. All right, number 2. X to the 6. You subtract those powers. All right, number 3. What do I have to do with my 3rd power?
Distribute.
So this is like a 3 to the 3rd, a to the 6th. Or 3 to the 3rd power is? 7. First 3, are we doing okay?
Mm-hmm.
All right. This one, what is 5 to the 0 power?
1.
What is 2 to the negative 1? 1 over 2. So this is just 1 plus 1 half. So 3 halves, or 1 1/2, or 1.5. All right. Then I started putting some trickier ones. We will do more of these later. I'm not just expecting you to remember all of this. But what did you guys do first on this one?
What I did was put the X on the bottom. I put that X on the bottom.
Okay, so you brought this x to the negative 2 down to the bottom. So you left the y to the 3rd up here. What did you do with the y to the negative 1? Okay. So then if you're multiplying, you add those exponents, so you get y to the 4th over x to the 3rd. Did you subtract your exponents? That also works. So you can subtract exponents because they're dividing. And then if you have any negative exponents, you just have to split. So a couple ways to get there, but we should get to the same answer. All right, number 6. We had one like this yesterday. So if we multiply the numbers, negative 8 times 3 times 2. All right, at x's, we have an x squared and an x to the 1st. So that's, okay, the y's, y to the 4th and y to the 6th. All right, number 7. What is negative 6 squared? This would be x to the. On the bottom, what is 4 to the 3rd? X to the. Y to the. All right, and then can we reduce? 36 over 64. What does that reduce to?
960.
Okay, x's, if we subtract exponents, 6 minus 3 is 3. And we still have that y to the 15th on the bottom. Right. Number 8. So, first if I take my 5th power through that parentheses, we get a to the, b to the. Okay, on the bottom I have 4a to the negative 3. What should I do with my a? Goes up to the top. Now, notice the 4 didn't. This is just like a 4 to the 1st. It had a positive exponent, so it stays on the bottom. So when I combine everything on the top, I have a 2, a to the, we have 10, 1, and 3, 14, b to the 5 and 1, b 6, my 4 on the bottom, so if I reduce, we get a to the 14, b to the 6, divided by 2. That one had a few more steps to it. Does that make sense? Number 9. What is negative 3 squared? A to the, careful, 8. Power to power, we multiply. So then if we multiply 9 times 6, get 54, a to the, and the final one. We have a negative out in front. Anything to the 0 power becomes This x has a negative exponent, so that just brings it up to the top with a positive exponent. The 5, though, just stays on the bottom. So it would look like this. All right. Any questions there? Let's finish our notes handout. So we reviewed the exponents, gave you some more challenging ones since we're discussing them together. Yesterday, we did our exponent rules. Then we talked about, where did I end off? We talked about like monomial, binomial, trinomial, right? Okay. So we've done that. Okay, so here we are. Monomial, binomial, trinomial, those are all special cases of polynomials, which just means you have one or more terms added or subtracted. In that polynomial, your exponents are always nice. No negative exponents, no fraction or decimal exponents, just whole numbers. When I say a coefficient, that is a number that is multiplied with variables. So for instance, if I said 5x to the third y squared, what is my coefficient? Okay, the degree is the exponent. Now, it's kind of like saying how many variables are there. Here, I have 3 x's and 2 y's. So what is my degree? How many variables do we have altogether? We have 3 of the x's and 2 of the y's. So altogether there would be 5. Alright, if there's just one variable, it's just the exponent. But if there are multiple variables, you add those exponents together. The degree of a polynomial is the highest degree of any term. So for instance, if I had 2x plus 6x cubed minus 9x to the 4th, what would be the degree of this entire polynomial? So I've looked for, yeah, the highest one. So that's just 4. So a couple examples of that. Did I actually print these on your paper? Look at me, I put 2 of my examples. I don't know why I put those 2 and none of the others, but I did. Okay, so if I asked for the degree of this one, first of all, how many terms does this have? 4. 1, 2, 3, 4 terms. All right, what's the degree of this term? How many variables? 5. What's the degree of this one? This one? This one? So my overall degree, you don't put them all together, it's just the biggest. So my biggest degree is 5. All right, you guys try the second one. We have 3 terms. This one has both an a and a b, so it's 2. This has an a squared, so that's 2. This one has 1a and 7 b's, so altogether there are 8 variables. All right. Is that okay? The last thing that we're going to talk about today is just working with polynomials. Do we know how to add, subtract, and multiply? So that's it. Should be the easier stuff. Probably easier than exponent rules. If I tell you to add these polynomials, how do I know what to add together? Like terms.
Like the 3 and the 2 is just like, they like have the same,
They have to have the same variables and exponents. Yep. When you add them together, does the x to the third change? No. So it's just the numbers in front. 8x to the third. So negative 10x squared, positive 10x squared. That's just 0x squared, so we can drop that out. Positive x, negative 5x. Does the order matter? If you wrote negative 4x plus 8x cubed. Yeah, technically, if I say like standard form, that's highest to lowest. If I don't specify that, then it doesn't matter. I won't count off unless I specifically say in my directions to write the polynomial in standard form, highest power to lowest power. Otherwise, any order is fine. What changes if I am subtracting the polynomials? Yeah. Take your negative, Bruce, we make this a plus. Change the sign on everything in that second parenthesis. And then we just add like terms. So we get negative 6m to the fourth plus negative 1, so negative 7m to the fourth. Negative 5m squared. Positive 21, negative 35. Gives me a negative 14. Could you guys try a couple just so I can walk around and make sure everybody knows what we're doing here?
Do it.
Okay. Alright, let's see how we did. So the first one, you should get 35, r to the third, s to the sixth, minus 10, r to the sixth, s to the third. Variables don't change, just adding and subtracting coefficients. Alright, D. This one did have an extra step. What do you have to do first? Good. Alright. So I distributed the negative 4 through there, so then combining like terms, we get negative 6c squared minus 22c. Perfect. Alright, looks like everybody remembered that. Final one. Do you guys remember how to multiply? Okay. Okay. So FOIL is like a binomial times a binomial. This one, we just have to basically take everything in the first times everything in the second. Alright, so if I multiply these, we get 12t to the third. Alright, we're adding the exponents on those t's. Plus 28t. So that's when I take the 4t through everything. Now if I distribute the negative 5, negative 5 times negative 2t, and negative 5 times 7. Everything in the first times everything in the second. Are we done?
No.
No, we always have to check if there's any like terms. 12t to the third, I don't have any other t to the third, so I just bring that down. Negative 8t squared and negative 15t squared, so negative 28t plus 10t minus do we remember that? Okay. What if I said did everybody have that one down?
Yeah.
What does it mean if I have a square outside my parentheses? We have to, means we have two of this parentheses. So we have to write that parenthesis twice and then FOIL. So we can't just distribute the square. We have two of the parentheses, and then we know to multiply that with FOIL. We get 9 plus 15x squared. Sorry, my handwriting is not really fast. All right. If you want, you can flip the order around. You don't have to, but at the very least, you do have to add those together and get a 30x squared. Is that okay? Can I do last example of the day?
Let's do it.
So x times x minus 1 times x plus 2. When I look at that, we have three things. A multiplication is commuted. That means you can do it in any order. So we just have to pick two of these and multiply them together to start. Which two do you want to multiply? X and x minus 1, just first two. Does that work? So to multiply those, we just distribute that x. So that gives us x squared minus x. Notice, I didn't distribute the x through both parentheses. Okay, you just take it through one. Now what do we do? So x squared times x would be x to the third. X squared minus x squared minus 2x. Combining like terms. So x cubed plus x squared minus 2. All right. Are there any questions? Okay, are we ready for our first homework assignment? I'll make it easy, okay? We have like 12 minutes. I'm going to put 5 problems on the board. Show me your answer. If you get them right, you're done, okay? Here are your questions. Once you get them done, you are finished for the day. Just show me your answer.